Hi, I, Deshmukh-Nikam, Assistant Professor at CM Institute of Pharmacy, Nare. This video is regarding a practical demonstration of surface tension determination by drop count method. This practical is included in the SY Pharm syllabus under the subject Physical Pharmaceutics 1 in SEM 3. So the aim of this practical is to determine the surface tension of given liquid by drop count method. Requirement in that first chemical, distilled water, and second is test sample. Then apparatus and instrument, we required beaker, stalinometer, stand, clamp, hot air oven, weighing balance and digital balance, etc. These are some references which are used for this practical. So, what is the principle behind this surface tension determination by drop count method? In that, we will first see what is the surface tension. The definition of surface tension is the force per unit length that must be applied parallel to the surface so as to counterbalance the net inward pull. There are different methods which are used for determination of surface tension. In that, we are going to use a drop method. And again, the drop method is again divided into two types. There is a drop number method and by drop weight method. Today's practical, we are going to use drop number method or drop count method for determination of surface tension. So what is the principle behind this drop count method? When any liquid is allowed to flow through a capillary tube, it forms a drop at the tip of the tube. It is increased in the size and detached from the tip when the weight of the drop is just equals to the surface tension at the circumference of the tube. So, the formula is W is equal to 2 pi R into surface tension. W is the weight of that water, pi and R is the diameter or radius of that tube. The surface tension is equal to weight of the drop divided into 2 pi R. So the instrument which is used for this is the stalinometer. So now we will see what is the stalinometer. So this is the stalinometer. Stalinometer is actually a simple glass capillary tube and it having a bulb at the middle. As you can see, there are 2 points, that is A and B. This capillary tube is having a capillary board at the tip. As you can see, the radius of this capillary is very narrow at the tip. So, this is a simple instrument or simple apparatus used for the determination of surface tension. Okay, now principle is the weight of the liquid falling from the capillary is approximately proportional to the surface tension of the liquid. Lower the surface tension of liquid, smaller the size of the drop forms, and more the number of drops formed from the same volume of the liquid. Here we can take an example of simple water and a honey. In case of water, the surface tension of water is very less as compared to the honey. So, the number of drop forms of honey is less as compared to the water. So now we will see what is the procedure for the drop count method. First, you have to clean the stalinometer with the water before use because the surface tension is highly affected with the dust. Second, fill the water or a sample up to the mark A on the upper stem of the stalinometer and mount in the vertically using a suitable stand. Then release the thumb from the top and count the number of drops formed from mark A to B using the volume of liquid for all the test sample. Repeat the procedure for 3 times and consider the mean of the number of drops for a further calculation. Determine the density of water and the test liquid using a density bottle. Then calculate the surface tension of unknown liquid using a given surface tension of water, that is 72.8 dynes per centimeter. There are some precautions you should be take for this method is use the clean and dry salignometer, hold the salignometer vertically only, and fraction of the drops can be calculated from the accurate calculation. Now the next part is the observation. Actually, the whole procedure is divided into two parts. That is a part 1, the determination of the density of liquid, and second part, determination of the surface tension. So in the first part, there is a determination of density of liquid. First, you have to take a empty specific gravity bottle and take a weight of it. The weight of this empty specific gravity bottle is denoted by W1. Here I have taken example where the weight of this that specific gravity bottle is 23.19. Then weight of the specific gravity bottle plus distilled water. We have to fill that empty gravity bottle with the distilled water, and total weight of that specific gravity bottle plus distilled water is denoted by W2, and it is denoted by and here the weight is 56.93 gram. Then third, weight of the specific gravity bottle. Then again you have to fill that density specific gravity bottle with the sample of which you have to find out the surface tension. So the W3 will be the weight of specific gravity bottle plus the sample liquid. Here it is a 51.06 gram. So for find out the density of any liquid, you have to divide mass upon volume. So more mass of that liquid you can easily find out by dividing the W3 minus W1, and volume of that liquid you can easily get from by dividing W2 by W1. From this formula you can get the density of that unknown liquid. Here the density of the liquid paraffin, which I have taken as an example, is 0.826 gram per ml. That we have to calculate this value. Then density of water at a room temperature is a standard value, that is a 0.997. Now the next part, that is the determination of surface tension by salignometer. For this we have to perform the experiment as I have discussed earlier also, and I will be giving you the small demonstration of the same in the after this presentation. So you have to suck the water in that salignometer up to the mark A, and then you have to release the tip and allow that water to fall down till the point B. While doing so, you have to calculate the number of drops which are formed by that liquid while falling from point A to B. By that you will get the number of waters, as well as you have to repeat the same procedure for that sample liquid and calculate or count the number of drops formed by that sample liquid. So from that you will get the value of N1 and N2, that is the number of drops of water formed A to B, and N2 will be the number of drops of liquid sample. Here the example is liquid paraffin. Okay, then from that values you can easily get the surface tension by using the formula surface tension is equal to ρ2 into N1 divided by ρ1 into N2 into surface tension of water. So here the ρ1 is the density of water, that is a gram per ml. ρ2 is the density of liquid paraffin or any sample. Then surface tension of 1, that is surface tension of water, and surface tension of sample. Then N1 and N2 will be the number of drops formed by the water and number of drops of the liquid sample. So as you can see, this is the observation table. Here is the number of drops. Okay, as you can see, you have to perform this experiment in a triplicate. Okay, and you have to take a mean of this number of drops form. Okay, then density of water, we have density of that unknown liquid we have already find out in the previous previous slide mean, and from that you will easily get the surface tension of the unknown liquid. So by this method you can easily find out the surface tension of unknown liquid by drop count method. These are the different questions which are can be asked you for the for the synopsis and the viva purpose. That is define standard, define surface tension and interfacial tension, and list different methods for surface tension determination, explain principle involved in stalagnometric method, and list equations to calculate the surface tension of liquid, and list different units of surface tension, mention the application of above experiment in the pharmacy. So this is a very simple experiment for determination of surface tension. Now we will see the demonstration part of the same.
So this video is regarding the practical of physical pharmaceutics 1. The aim of this practical is to determine the surface tension of given liquid by the drop count method. Okay. So the total procedure is divided into two parts. There is a part 1, in that determination of density of unknown liquid. Okay. And second part is determination of surface tension by stalagnometer. So the instrument which is used for this practical is the stalagnometer. The stalagnometer is a simple capillary tube, glass tube, where this is the bulb at the middle and point A and point B. For that you have to suck that liquid up to the point A, and after that you have to release the drum, and you have to count the number of drops which are formed from point A. That liquid flow from point A to point B. That is a simple principle behind this stalagnometer. Then in the procedure, first the determination of density of liquid. First the weight of empty specific gravity bottle. Here I give an example like 23 gram. Then weight of specific gravity bottle plus distilled water. That is the W2. From that we will get the mass of the water. Then the weight of specific gravity bottle plus sample liquid, that is W3. Then density of sample A by calculated by equation mass of the liquid divided by mass of the equal volume of water. So that we will get from this values, that is the density of that water, density of sample is equal to W3 minus W1, W2 minus W1. From that we will get the density of unknown liquid. So here the density of unknown liquid is 0.82, and the density of water at room temperature, this is standard value, it is 0.997 gram per ml. This is the standard value. Now the next part is the determination of the surface tension by stalagnometer. Now we will now I will give a small demonstration of the stalagnometer. Okay, this is the stalagnometer. There is a bulb over middle and point A and point B. Okay, as we are calculating the relative surface tension, we are comparing the surface tension of unknown liquid with the water. So I have taken first water. Okay, you have to simply just suck the water to point A. Now I mount this stalagnometer on stand. Okay, now I am releasing dip. Now I have to calculate the number of drops falling from point A till point B. As this is capillary inside, the diameter of this capillary is very small, so you will get a small droplet. So I have calculated the number of drops of water. So the same procedure you have to repeat for 3 times. It is a triplicate. So the number of drops of water formed is 42, 43 and 42. From that you will get the mean. Okay. And the same procedure you have to perform for again for sample A and sample B. Okay. So now from this you will get the N1, N2 value. Okay, that is number of drops of water as well as unknown liquid, and from that you have to calculate the density of unknown sample by this calculation. The same calculation you have to repeat for sample B as well. Okay, then you have to write that density of unknown liquid A and density of unknown liquid B. Okay, then from this density and number of droplets you can calculate the surface tension by using the formula density of sample into number of droplets of water divided by density of that unknown liquid into number of droplets drops formed by the unknown liquid into the density of water. As we know the value of density of water and the number of droplets, you can easily calculate the surface tension by this formula. Okay, so this is a very simple procedure. That is determination of surface tension by the drop count method. Thank you.